curve given here has an asymptote with equation y is 2, poles when x equals 3 and x equals negative 5, a 0 at x is negative 3, and a y-intercept at negative 1/5. We want to find all possible values of a, b, c, d and e, and we're told that d is greater than e. Well, the first one is this a up here. That's the easiest thing to get at. If we think about x tending to infinity, we're told that y tends to 2. And that must mean that a is equal to 2. Just think about the leading term on the top. That would be ax squared. On the bottom it would be x squared. So ax squared divided by x squared is a. It follows that a must be 2 if that's our horizontal asymptote. Now for poles, at x is 3 and x is negative 5, the denominator must be x minus 3 and x plus 5. So this is plus d and plus e. D is greater than e, so the plus 5, so d must be 5, and then e must be negative 3. Now, let's look at this y-intercept here. That happens when x is 0. So if x is 0, the top part of that is BC, and the bottom part is DE. So that's got to be negative 1/5. Now we know that DE is negative 15. So we can say negative BC over 15 is negative 1/5, and it follows that B times C is equal to not 15, but 3. 15 divided by 5. So, let's look at the idea of a 0. So what we know is we've got 2x and x here, like so. So this is plus c and plus b. So if we're going to have a 0 when x is negative 3, what we could have is 2x plus b, x add 3, like this. So that would give us that c is equal to 3. Now if that's the case, going back to here, b would have to be equal to 1. But what we could also have is 2x plus 6 and x plus c. So this would mean that b was equal to 6. Substituting back to here, that would mean that c would have to be a half.